friends, welcome back to Pharmawise. Today we are going to discuss a very important topic from pharmaceutical analysis, and it is neutralization curve. If you are studying pharmaceutical analysis, you must be knowing that this question will be definitely asked for the long answer question for 10 marks. So exam point of view, this point is very important, and today we are going to prepare this point very well. So we are starting with the concept of neutralization curve, and then we will see how to plot the neutralization curve, how to derive the points on the curve. So let's start with the example of neutralization curve for strong acid, strong base. But before going to that, let me tell you what is neutralization curve. Or let us start from what is neutralization. So whenever an acid reacts with a base, they form salt and water. This reaction is called as neutralization. Now, if the reaction happens in aqueous medium, this aqueous acid-base neutralization reaction forms the basis of aqueous acid-base titrations. Now, what are titrations? These are the laboratory methods for quantitative analysis of samples. Means we have to find out the unknown concentration of a sample, then we can go with the titration method. So in titration, we are having a titrate, a titrant and an indicator. So what is titrate? Titrate is usually taken in the conical flask, and it is the unknown concentration sample, or we can say it as analyte, because we will be analyzing the sample for its concentration or for its quantity. So it will be analyte, or it is called as titrate. Then we fill the burette with a standard solution. Standard solution is nothing but the solution of known concentration. So the concentration is known, it is standard, it is filled in the burette, and it is referred as titrant. Now when the reaction between titrate and titrant starts, at the equivalence point, both their quantities are equal and the reaction of neutralization is over. That point is referred as equivalence point. Now after the equivalence point, the indicator which you have added shows a visual color change which indicates you the completion of reaction. So indicator is an auxiliary substance which indicates the end point of or completion of reaction by showing some visual color change. Okay, so now when you know what is titrate, what is titrant and what is indicator, let's discuss what are aqueous acid base neutralization titrations. These are nothing but one of the entity, like titrate, if it is acid, your titrant will be base, and they will yield salt and water in the end. So these kind of titrations are called as aqueous acid base neutralization titrations. So now there are four possibilities. Either you react a strong acid with strong base, or you react a weak acid with strong base, a weak base with a strong acid, or a weak acid with a strong base. So these four cases are generally studied, and neutralization curves are generally plotted for these conditions. Now we are coming to what is neutralization curve. So whatever course of titration we are following, means we are taking titrate in the conical flask, we are adding titrant from the burette. So whenever we start adding titrant from the burette, what are the changes of pH that are taking place in the solution? That we will record, and we will plot the pH values on y-axis against the volume of titrant added on the x-axis. So a plot which gives you the course of titration and is plotted by taking pH values on y-axis and volume of titrant added on x-axis is called as a neutralization curve or a titration curve. So today we are taking an example of strong acid, strong base titration curve. I'll try my best to explain this curve to you. So let's start. We are taking 100 ml 1 normal HCl, which is a strong acid, in the conical flask, and we are taking one normal NaOH, which is a standard solution, as a titrant in the burette. So our titration is against HCl and NaOH, right? HCl against NaOH. So it is a strong acid, strong base titration. We are using phenolphthalein indicator for that matter. Now, let's begin with the titration curve. As I told you, it is nothing but a plot of pH on y-axis and volume of titrant added on the x-axis. So I will put some values 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And here I will take 10, 20, 30, 40, 50, 60, 70, 80, 90, 100, 110, 120, 130, etc. Okay, so now it is clear. Okay. So we will start with the example of strong acid, strong base titration. Now pay attention. We will divide the course of titration in 4 points. First point will be before titration begins. What is the pH? Then we will study what is the pH during the process of titration. Then we will find out what is the pH at equivalence point, and then we will find out what are the pH changes after equivalence point. So we will find out the pH value for each of the level, and then we will plot those values on the graph. Okay. So we will start from the first point, before titration begins. Now what is there in the conical flask before titration begins? It is 100 ml 1 normal HCl, isn't it? Now HCl is a strong acid. So strong acids dissociate completely to give ions. Means the amount or concentration of strong acid will be equal to the concentration of H plus ions formed. So what is the concentration of acid? It is 1 normal. So automatically H plus ions will be also 1 normal. Now you know the equation. H plus is equal to pH is equal to negative log of H plus, concentration of H plus. This is the equation for pH. We want to find out the pH value now before titration begins. So we can use this equation. So I will put negative log of 1 because the concentration of H plus is 1 normal. So log 1 is 0. So the value will be 0. So the pH for a strong acid, strongest titration will start somewhere from 0. Okay, so we have got 1 point. So we'll start with the 0 point. Okay. Then we will proceed towards during the titration. During the titration. So during titration, what will happen now? Imagine this is the conical flask. Here it is 100 ml 1 normal HCl. Now what you do is you are adding 1 ml NaOH from the burette. You added first 1 ml of NaOH from the burette. Now that 1 ml of NaOH must react with the 1 ml HCl in the conical flask. So they will neutralize. So what will be the acid concentration remaining in the conical flask? It is 99 equivalents out of 101 ml, because when this 1 ml is added, the total volume becomes 101 ml. And what is the acid equivalents which are there? They are 99. So after addition of 1 ml NaOH, concentration of H plus will be 99 upon 101. Now I will actually calculate what the concentration comes. So if I calculate 99 divided by 101, it comes, I was trying to calculate the values using an old mobile calculator, but it seems that mobile is not working. So I have calculated some values for you, and now we will discuss. So what I was telling you, the concentration of H plus when addition of 1 ml NaOH is over is 99 upon 101. This value, if you calculate, it comes 0.98. Okay. Now If we take negative log of 0.98, the value comes 0.008. Means your graph will start from 0 and the next point on the graph when 1 ml of NaOH is added is the pH of 0.008. So we will go on plotting the points and we'll calculate the points here. So for addition of say 10 ml of NaOH, what will be the H plus ion concentration? It will be 10 ml NaOH is down. So the total volume becomes 110 and 10 ml HCl is reacted with NaOH. So what is the acid concentration remaining? It is 90 equivalents of acid. So 90 by 110, if you calculate, it comes 0.81, and if you take negative log of 0.81, it comes 0.09. Okay, so the next point for 10 ml addition, it will be 0.09 somewhere here. Okay, so the points are going very gradually, as you can see. Now let's go to 50 ml addition. When 50 ml addition is there, concentration of H plus, as you can guess, is total out of total volume 150. 50 ml must be reacted. 50 ml is present. So it comes 0.33. Negative log of 0.33 will be 0.48. So you can see the change is very gradual. Now let's move on to 90 ml addition. For 90 ml, concentration of H plus will be, yes, you guessed it right, 190 total volume, but acid will be only 10. So it comes 0.05. So pH will be negative log of 0.05, which is equal to 1.3. You can easily use calculator log function to calculate the values. So 1.3 is the pH when 90 ml of NaOH is been added. Now let's find out one more point, 99.9 ml. So what will be the H plus ion concentration? Yes, 0.1 upon 199.9. 199.9 is the total volume, but 0.1 acid is still remaining. So the value comes 0.0005 and the pH value means negative log of this comes 3.3. Now you can see, if we plot these points on the graph, the change will be very gradual till you go 99.9 and 3 is here, 3.3. So somewhere here our points will come and the graph will look like this. The graph will look like this. Initial graph is very gradually increasing. Now what happens when you add the last 0.1 ml of NaOH, and now there are 100 ml NaOH in the conical flask which have totally reacted with 100 ml of HCl which was there in the conical flask. Total volume becomes 200 ml, but here the reaction is over. So what is there in the conical flask? Only salt and water. This is the equivalence point, and being only salt and water, the solution will be neutral, and the neutral solutions have the pH of 7. So immediately after the 0.1 ml addition, after 99.9, your pH will shift to 7. Here your pH will go. So it will be like this. So at the equivalence point, there will be an abrupt change in the neutralization curve. Okay, from 3.3 directly you are going to 7. So this curve is important. This abrupt change is important in the neutralization curve, which indicates the completion of reaction. Now this is the point at equivalence point. So we have studied 3 points. Before titration begins, what was the pH? It was 0. During the titration, how the pH value changed from 0 to 3.3, and at equivalence point, how it shifted from 3.3 to 7. Now let's see what happens after equivalence point. If after equivalence point I'll add 1 more ml of NaOH, excess ml of NaOH, then it is going to give OH minus ions in the solution, because there are no H plus ions left. So OH minus ions will be contributed by the excess of NaOH, and we can find concentration of OH minus ions after addition of 1 ml excess NaOH. Okay, so we will find the concentration of OH minus ions after equivalence point. So how it will be calculated? It is the 1 equivalent of base in 201 ml of total volume, right? 100 ml HCl plus 100 ml NaOH has given you the value 200 ml. Now you have added 1 more ml of NaOH. So the total volume is 201 ml. Out of that, 1 equivalent is the base concentration. So if you calculate 1 by 201, it comes, I have calculated it already, it comes 0.0049. And if you calculate, take negative log of this value 0.0049, it comes 2.3. Now don't forget, you have taken negative log of OH minus ion. So this value is POH. But we are plotting pH value, so we cannot take POH value there. So we have to convert that POH value to pH value. Now how you will do that? With the very simple equation of ionic product of water. pH plus POH is pKw. pKw is 14. So pH plus POH is 14. So if my POH is 2.3, my pH must be 14 minus 2.3 comes 11.7. So after equivalence point from 7, my pH will go to 11.7. Means you can see the pH will go here. Approximately I am trying, but it will go there. Then again, if you go on plotting the curves or points, they will start going gradually like this. So this is how the neutralization curve of strong acid, strong base looks like. It basically is a S-shaped curve, but has a very abrupt change in between. Initial change is very gradual, then there is abrupt change, a straight line, then again there is a gradual change horizontally. Okay, this is how neutralization curve is plotted. Now, what is the significance of neutralization curve? If you can see, from where the abrupt change has started, here in this point it is started from 3.3 and it is went till 11.7. So if you take a middle point of this straight portion of the curve, it gives you the equivalence point of the reaction. Okay, so if you plot the middle point of straight portion of a neutralization curve, you will get the equivalence point pH. pH at equivalence point, and pH at equivalence point is very important for selection of a suitable indicator. For selecting a suitable indicator, you should consider what is the pH at equivalence point. Your indicator range should be within the pH plus minus 1 of your equivalence point. Okay, so from this you can select a very good indicator which will give you a smallest titration error. Means for this kind of titration, if the range is between 3 to 10 or 3 to 11, this range falls very well within the range of phenolphthalein, right? So you can use phenolphthalein for a strong acid, strong base titration. But if you are using a different concentration, or if you are getting a different range, then you should find an indicator whose range matches with that range, so that the indicator is able to give you the exact endpoint and the titration error will be minimum. What is titration error? After equivalence point, immediately your indicator should show the color change. If it is taking too much time after the equivalence point to show you the color change, that error means equivalence point and end point. When your indicator shows the color point, that point is called as end point. When actual reaction is over, that point is called as equivalence point. This gap is called as titration error. And you should always try to minimize the titration error as much as possible. And you can do it by selecting a proper indicator. So, A neutralization curve can help you find a suitable indicator for that kind of titrations. So we have discussed a neutralization curve for strong acid, strong base titration. I hope you have understood it. I don't want to stretch the video so far, so I'm stopping here. I'll make another video for the neutralization curve for weak acid and strong base, which is again very important, and in the 10 marks question you have to write that also. Okay, so I'm stopping here. Let's meet in the next video where I will discuss weak acid strong base titration in detail. Bye bye.